Hello, greetings students. Welcome to this video lesson. So I hope everyone is ready to learn new thing. So this week we will be discussing about rational algebraic expressions and their domains. And as you can see, I have this presentation. Actually, this is a video screen recorded. I use the DOST, Department of Science and Technology application. Okay, so credits to them, and I hope you like this. You can search it in your Google Play Store or what. So let's start. So as you can see, right now we have this mango tree, and the girl you saw before is Tala, and Tala wants to separate the rational and irrational numbers. So here's what are we going to do. Tap and hold the mangoes to see if the numbers they have are rational or irrational, then drag them to the correct basket. Are you ready? Let's do this. Let's start this first mango. 9/4. So let's drag it to its place. So let's drag it to, okay, great work. So it's correct, it's rational. Continue, you have square root of 3. Okay, it is irrational. Very good. Continue. 3.1416, it is irrational. Another mango. We have 25/100, it is also rational. Another one, last two, we have square root of 2, and this is irrational. Next, we have 16, and a whole number is also rational. Let's continue. Next, Tala is sending her gratitude for your help. So why are the following real numbers considered rational numbers? A, because they are real numbers. B, because they can be written as quotient of two integers. So what is your answer? Is it A or is it letter B? Go. Think of your answer, and that will be the definition of rational numbers depending on your answer. And our answer is letter B, because they can be written as quotient of two integers. So always remember that is rational algebraic expression numbers. Now, let's read this. Rational numbers are real numbers that can be represented as the quotient of two integers. Note that since rational numbers are real numbers, then the quotient must not have 0 as divisor. Similarly, we can have a quotient that consists of polynomials. Such is called a rational algebraic expression. Let's continue. Let us check if you still recall what polynomials are. Now this boy, as you can see, that his name is Sinag. So we're going to help Sinag to catch fishes or those fish with polynomials. Okay, so where are we going to start? Is it with the color green, pink one, the orange one, violet, or blue? So we have AB plus C, X plus square root of 3, A plus B plus C. Which one will be catch first? Is it the pink one or the violet one? Okay, so we have the green one. Excellent. Next, A plus B plus C. Next, X plus 2. Okay, we catch X plus 2. What else? Okay, 4W squared plus M. And what's left are these two. Okay, click the fishes that have polynomial tags to catch them. So we're not going to catch these two because we believe that they are not polynomials. we cannot click them because they are not polynomials. This time, we're going to find the 8 rational algebraic expressions. We're going to click them one by one. Okay? Again, find the 8 rational algebraic expressions. Click on them to reveal more of the picture. So, this time, I will click any. Okay? So, we will identify whether it is rational or not. So, as you can see, we have 3x plus 2, 5m, x plus 1 over x plus 5. Oh no! This one is not algebraic expression. 2 over x minus 3. And later on, we will know why. Why 2 over x minus 3 is not rational algebraic expression. So, the other one, oh no, another not a rational algebraic expression. We have square root of x plus x over y. Let's know later why. And the rest are example of rational algebraic expressions. Very excellent. Thank you. Let's continue. Now, there's restriction in definition of rational algebraic expressions, and that is the denominator of a rational algebraic expression cannot be equal to 0. And here's the explanation why 2 over x minus 3 is not an example of rational algebraic expression. If we set the value of x as 3, we will get 2 over 0. So this is not rational algebraic expression because it leads us into undefined. Okay, so just like the other one. Now let's try to answer this. X plus 7 over x minus 2. What is the value of x? That will make it 0. The denominator will become 0. The answer will be, of course, 2. 2 minus 2 is 0. Okay? To continue. I hope you are following. Next, in 4 over 12x, x is not equal to, what are we going to multiply to 12 to make it 0? It is 0. So, that's it. Next, let's continue. In 4x minus 8 over 2 minus x, what is the value of x? It is, yes, it's 2. 2 minus 2 is 0. So, denominator, ang concern natin that it should not be equal to 0. So, 3 plus x. What is the value of x to make it 0? So, the value of x should not be equal to negative 3. How about in 6 over 10 minus 2x multiplied by 5? 10 minus 10 is 0. Next, the set of all possible values for the variables in a rational algebraic expression is called the domain of the expression. Okay, again, so for example, we have 2 over x minus 3 and we get kanina that x is not equal to 3. So therefore, this is how we're going to write the domain. It is the set of all x such that x is an element of real numbers, that's R, where x is not equal to 3. Meaning, all of real numbers except 3 can be the value of x. Why not equal to 3? Because it will lead us to undefined answer or rational undefined number, which is having 0 as our denominator. So again, the braces, and then we're going to read this as the set of all x such that x is element of real numbers. How about this one? We're going to find the domain, and the answer will be, should be positive 5 or negative 5. The set of all x such that x is an element of R, where x is not equal to positive 5. Yes, that's correct. The other one, is it A or B? Positive 2 or negative 7? Positive 2. Very good. Next, how about 4 over 12x? 0. So the set of all x such that x is element of real numbers where x is not equal to 0. This one, 3 or negative 3? Letter, of course, letter B. Work. Very good. Continue. 6 over 10 minus 2x. Very good. By the way, you can pause this while you are reading, so you have time to grasp more clearly of the lesson. Okay? I hope you enjoy this application. You can search for the Department of Science and Technology, DOST applications. Game, they are making game simulations, etc., etc., regarding the math lessons. So, see you next time, and I hope you learn from this video. Thank you very much.